Good morning, good afternoon, good evening, or good night, Mr. and friends. My name is Bryan Hogan, with student number 1906301305. So today, I wanted to explain about the fluid mechanics third assignment that was given by Mr. Dai during the fifth meeting of fluid mechanics after midterm. So in this assignment, Mr. Dai asked us to do the simple experiment that are related to the fluid dynamics. And I decided to do the experiment by using 4 plastic bottles, solder, stopwatch, ruler, and tape. This experiment is to find the relation between the diameter of the hole and the water discharge, the velocity, and the hydrostatic pressure in the bottle. So in this whole picture, the hole diameter in this picture is 0.01 meter. The hole diameter in this picture is 0.012 meter. The hole diameter from this picture is 0.014 meter. And from this picture, the hole diameter is 0.016 meter. And here are the following steps to do the experiments. The first step is I prepare the 4 plastic bottles that has the same amount of volume. And next, I create the circle hole by using the solder. The center of the circle hole is at h equal to 15 cm or 0.15 meter from the ground. The first bottle has 0.01 meter hole diameter. The second bottle has hole diameter that is 0.012 meter. The third bottle has the 0.014 meter hole diameter, and the fourth bottle has 0.016 meter hole diameter. The next step is I cover each of the hole using the tape. Then I fill the bottle until height equals to 24 cm or 0.24 meter from the ground, and do not close the top of the bottle. Put the bottle on the flat ground, and for hole diameter equals to 0.01 meter, open the tape and count the time that the water takes to come out by using the stopwatch. Also measure the furthest distance that the water comes out, like this. For hole diameter equals to 0.012 meter, I repeat the same step that I used for the bottle that has 0.01 meter hole diameter. And for the hole diameter of 0.014 meter, I do the same step with the bottle that has 0.01 meter. And for the hole diameter of 0.016 meter, I do repeat the step, which is count the time that the water needed to come out from the hole and measure the furthest distance that water comes out. And after that, I put the data on the table, and here are the following data. Then for the velocity, I calculate the velocity by using the Torricelli theorem, and the water discharge by using the following formula, like this. Velocity equals to distance divided by time, and water discharge equal to velocity times the area of the hole diameter. The velocity can be shown as distance divided by time. And I calculate the water velocity and water discharge from the following data, and I got this number. Then for the hydrostatic pressure, I use the following formula. Hydrostatic pressure equals to density times gravity acceleration times the height of the water from the top of the bottle to the center of the hole. For each bottle, the depth of the water from the top to the center of hole that I use for this experiment is 9 cm or 0.09 meter. 9 centimeter is got from 24 centimeter, which is the amount of water that I filled to the bottle, and 15 centimeter is the location of the center of the hole diameter. And the calculation will become like this. All of the hydrostatic pressure is 882.9 Pascal. And the conclusion that I got from this experiment is the bigger the hole diameter, the greater the water velocity, and the bigger the hole diameter, the greater the water discharge. The hole diameter size doesn't affect the hydrostatic pressure. That's all my explanation for the steps that I used to do the fluid mechanics third assignment. Sorry if any words are not pleasing. Thank you for listening to my explanation.